welcome back students and friends. In the last lecture we looked at developing the level of service for multimodal facilities such as stretch of a road. Now we will look at some of the design aspects of multimodal transfer facilities. In this lecture we will be introducing you to the 6 different design principles that have to be followed when you design an intermodal or a multimodal facility which actually integrates the different modes. Then we would get into what type of how much area or size of each of the elements within the transfer terminals that you have to provide, and then we will introduce you to certain steps that need to be followed in order to review the design process. So, when we talk about transfer terminals or when we talk about multimodal terminals, what essentially we are talking about is this small domain of a small domain which is an overlap between your understanding of a transit oriented development, your understanding of a station area development, and this larger concept of multimodal transportation planning. So, if you look at multimodal transportation planning and TOD as two sets, then the intersection of those two sets is where this transfer terminal concept lies in. That means, you have to have facilities that cater to different types of modes. Just having a standalone or believing that a station facility is just a standalone facility for one mode will not promote multimodal transportation. It will only promote individual modes of transportation. So, when you design a station, say for example for a bus, you also have to keep in mind that maybe at this stop you have to provide good facilities for, say for example, bicycle parking, because maybe people will come here using their bicycles, park the bicycles, and then take the bus or the rail. So, although we may look at it, we may look at the terminal design as a terminal which is designed for bus or rail transportation, but when we start thinking along the lines of multimodalism, then we have to think that this terminal is not only catering to the bus or the train mode, but also it is catering to the cycle mode, bicycle mode, or maybe it is also catering to the two-wheeler mode. Lot of motorized two-wheelers people will come and park and then take. So, we have to revise our thinking in this manner, so that the design elements in that station building also cater to these other modes, right. It should not only exclusively cater to the bus or the rail mode, but it also has to cater to these other supporting modes. That is how you encourage or you promote the use of these larger public transportation systems, and hence these terminal areas becomes very important. Okay. So, that is the entire concept or entire theory behind you wanting to develop the multimodal transfer facilities or multimodal hubs or transit centers that we look at now. You have to keep in mind this ideology or this idea. So, when we talk about, say first type of facility, if we call them as transfer facilities, what essentially we are saying is that every station has to be viewed from the point of view of a transfer facility, right. Imagine even a just simple bus stop. Now, if you think of a bus stop as a facility that is only needed for the bus, right. If it is only needed for the bus, then we would be amiss in our thinking, because eventually once we get down from a bus, we have to take another mode to reach to our destination or our home or wherever we are going, right. So, the bus stop is also in a sense a transfer facility or a multimodal facility, where two or more other modes have to be well integrated. So, as the simplest example is, maybe the bus stop should be connected with a good network of sidewalks, for example. So, if you have good sidewalks, then what the bus stop essentially becomes a transfer point between the bus and the pedestrian mode, right. It becomes a transfer point. Now, the people have a safe facility to walk back to their home or walk to their final destination, and also the facilitates the increasing use or the greater use of the bus mode as a means of travel within the city. So, this is how we should frame our thinking when we talk about multimodal transport in the urban transportation concept. Every terminal or every transfer terminal that we design, we should not think that that is only for one mode, right. So, BRT, for example, a BRT station that you see here, it is not only for the bus, it is not only for the bus rapid transit, right. You have to have, for example, look at this, you have to have good facilities for the pedestrians to cross once they get on or once they are trying to get off the bus, right. Otherwise, since this is a median type of a BRT, nobody would be able to access this station from the footpath that is on the sides of the road, right. So, in order to access this, you need good connections, you need a zebra crossing to cross. Otherwise, the BRT station, if you just think of this station terminal as a terminal that serves only the bus, then you would not be able to develop a multimodal transportation network for your city. You have to think of these terminals as multimodal terminals. Okay. So, that is the simple example of a transfer terminal, right. It is just transferring a set of people or users between from one mode to the other mode. Now, you look at the various points that you should take into consideration. The station element should be consistent with the existing stations. So, once you are building a new station, maybe do not design the station so very differently than any of the existing stations. Then there will not be this ease of movement for the people, and they would be lost suddenly when they come to a new station, this station thinking that, oh, how do I get off, because they are not very familiar with this new design. So, you may aesthetically make it a different looking station, but at least have the functional elements within the station that have some consistency within your network. The station area vehicle requirements should be consistent. I mean, one station area has two platforms versus the other station area has only one platform. That makes it again a complex situation. So, have your vehicle requirements consistently across the stations. Your garage facilities have to be now coordinated. So, maybe your BRT buses are a little bit buses that are longer, right. Maybe they accommodate more passengers, whereas your regular buses that run on the street may be some shorter buses or fewer capacity buses. So, the garage facility that you had maybe was only for those shorter buses, but now that the BRT system has come in, you need to have a garage that also facilitates these longer buses. So, facilitate meaning you have to have bus bays that are long enough for these buses to park. So, again, when you are designing these things, do not just again design a different garage for the buses that are going to run on the BRT corridor. Maybe retrofit the existing bus garage so that they can be used now for different types of buses. That also becomes not multimodal. In this case, both are buses, so there are not multiple modes, but there are different categories of buses maybe. So, think in those lines even within one mode, right. Again, transfer terminals, if you look at the primary functions of these stations. So, functional elements, remember, some elements are functional elements, whereas other elements are maybe aesthetic elements. So, functional elements are very crucial in designing of any station, and that is what should be consistent across stations, right. So, the first function they have to be providing is to provide access to customers of all ages and abilities, right. So, you have to have ramps so that differently abled people can access these stations. You have to have those ramps will enable people, even abled people, to carry their luggage to the station. It will help people who are of older age to change levels if your station has multiple levels. So, all of these are functional elements that has to be taken care of by each of these stations. access for pedestrians and people using wheelchairs or bicycles, including providing bicycle parking. So, that is the parking is another element that every station design has to take into consideration. Platforms, there has to be certain size and certain width of platforms that have to be provided, which would enable the circulation of users that are using the station. Waiting shelters for all public transit routes serving that station, right. You have to have shelters. More and more public transport agencies are now providing at least some basic type of shelter at every stop or at every station. You hardly find in any good public transportation network, you hardly find any stops, bus stops or train stops that just has a signpost and nothing else. There has to be a shelter for protection against harsh weather, so that people who are trying to access these public transportation systems are taken care of. And provision of for short term pickup drop off of transit patrons by shuttle, taxi, etc. So, what the other thing that usually people are against at providing at the against for providing at the stations are permanent parking, because what that encourages or what that allows people to do is drive to these metro stations or BRT stations and then park and then take the metro or the BRT. That usually does not solve the purpose of urban or public transportation, because you are still making a part of your trip by a private vehicle or a single occupancy vehicle. So, it is not fulfilling the sustainability that we are trying to achieve in urban transportation. So, hence you do not provide for long term parking or full day parking for vehicles, but you should provide some minimum basic parking that will allow people to maybe pick up and drop off passengers from those stations. Now, these may not be provided at all stations, but maybe at terminal stations or maybe at major stations where there is a lot of activity, a big residential complex or a big commercial complex or something. So, such stations should have at least the facility to a circulation pattern, for example, to pick up and drop off, or 10-minute parking where people can wait as the bus is arriving or as the train is arriving, and to pick up and drop off their either child or friend or spouse or whoever it is. So, that type of facility should also be thought of, because that is one of the primary functions of any station. Similarly, you can then think of another category of station calling a transit center. Now, a transit center is a little bit bigger and has more infrastructure associated with it, because now at a transit center what happens is you are connecting two modes that are that have scheduled connections, right. So, you may be developing a transit center where suburban or intercity rail is connected to intercity bus. So, there may be, so they have only scheduled connections. Scheduled means they run on some fixed schedule, right. These centers enable these are large centers, these are large infrastructure pieces of infrastructure which needs a lot of land, and what happens is once people arrive from a smaller city to this transit hub or this transit center by bus, then they wait a considerable amount of time before the scheduled departure of their train may be from the same hub or transit center. So, what this requires, you will see that these usually serve higher daily passenger volumes, and it requires a larger area, passenger waiting area, because there will be passengers who will be waiting for a longer period of time at these centers. But these are very, very effective centers now, otherwise you would have had two different pieces of infrastructure. One is a bus terminus versus another is a rail terminus. Now, both of these are integrated into one big transit center. So, that allows for saving of land, which is prime in many of our urban areas, and also makes the transfer much more seamless between these two modes. A smaller variety of those hubs or transit centers could be something called a transit layover, where may serve a location where transit vehicles, either bus or rail, layover or wait to enter the service location. So, these are end of line stations, or even a station that is beyond the end of the line, where the transit is waiting for to start its service, right. We have learnt about what is the layover time. So, at the end of a run, the transit vehicles have to turn around to begin a new run. So, while they turn around, there may be a facility there for the drivers to wait, and so on and so forth. So, that may be a transit layover facility. Park and ride are very have been tried extensively in the urban areas to promote public transportation, where people do drive their vehicles, and they have whole day parking over for a day, or even overnight parking sometimes. They drive, they park their private vehicles there, and then they take some other form of public transportation, either a bus, or you even have park and fly facilities, right. You have remote parking places for airports nowadays, because land, especially for airports that are within the city boundaries, land is becoming sparse. So, what happens is you have remote parking from where you have shuttles that take you to the actual airport terminal, right. So, those are park and fly hubs or centers. So, now that you understand what is a multimodal system, so every kind of station area or a hub or a center is not just a hub or a center that serves one particular mode, but it is a center that serves multiple modes. So, you have to design that center keeping in mind the necessities of these 2 or 3 modes that it is serving, not just design it keeping in mind one particular mode. So, that is the entire idea. We will look into park and ride a little bit more detail, because that is has been extensively tried and has been also found to be beneficial in attracting people to take urban public transportation. Now, if you look at 6 design principles for these stations, the first design principle is how to locate a station, and we have extensively looked at and given you mathematical formulations of how should you determine the spacing between stations. So, keeping those formulations in mind, you already know where to locate these stations. Usually these stations should be in places that attract visitors or workers, near major trip generators, for example, maybe movie hall, shopping malls, schools, etc. And hence land use plays a very important role of where you locate these stations. Provide frequently used services near a transit station, so shops, restaurants and childcares. So, that is the whole idea of transit oriented development, is to design your station as not just a station terminal, but as a multi-use facility. You can have restaurants, you can have even office blocks, you can have residential blocks around, or even multi-storied buildings on top of the transit hub or the station, and that makes it a TOD or a transit oriented development, and that serves that becomes a very good example of achieving sustainability in urban transportation. To encourage patronage of business, place them between vehicle parking areas and the transit stop, right. So, all of these where to exactly locate a transit station is one of the design principles that you have to keep in mind when you are thinking about location, when you are thinking about developing a station. So, the first design principle is look at the transit station location. The second is station circulation. So, once you have decided where you have to locate your station, then you have to design appropriately for the circulation within the station area. And the hierarchy of circulation is obviously the pedestrians comes first in circulation, because people will be walking mostly around your within your station area. So, how do you appropriately incorporate all the pedestrian space requirements, which we have already looked at again when we developed the level of service for pedestrians. There was an example for a terminal, for a station area level of service as well. So, that will help you in designing the circulation areas for pedestrians. Then of course bicycle feeder buses, these are all outside the station coming into the station, right. So, your design, when you design a building, you have to have circulation areas for buses, feeder buses, taxi, auto drop off, and also cars if you decide to provide some parking for cars. So, station circulation is the second principle that you have to remember while designing a station area. The third is bicycle and pedestrian and bicycle parking. I mean, it's pedestrian and bicycle parking. Obviously, there is no pedestrian parking. So, when we talk about parking areas, bicycle parking was never given much thought until the turn of the century, where people really started to, or urban planners and urban transportation engineers started to research much more into how bicycling can be beneficial to the public transportation network. They found that bicycle is a inexpensive mode, is an environment friendly mode. Although they cannot take you long distances, but they can definitely bring you to the nearest metro station or a BRT station or a bus station, right. They can definitely, people bicycle at least 3, 4, 5 kilometers effortlessly. An average bicyclist is what I am talking about. If you are a regular bicyclist, you can go even further, but even an average bicyclist can bicycle every day for 3, 4 kilometers. And if you are within that range, if your metro station or BRT station is within that range, then you should be encouraged to get your bicycle to the station, and once you get it to the station, then you have to have proper parking. Otherwise, informal parking of bicycle that we often witness around stations does not attract new people to take the metro stations. Those are mostly people who would be captive riders, who would be using the metro station if you do not provide appropriate parking, because nowadays even bicycles are expensive. Some of the bicycles, new bicycles, are expensive. So, you have to provide for good parking spots, safe parking spots in order to encourage people to use BRT or MRT or any form of MRT, right. Then it is access. We have already looked at access. It is usually encouraged that access be provided at grade. So, for example, if you have such an grade separated access point, which are very popular in or which have been extensively built in to connect the Mumbai suburban railways to various points of their road network, but they often face the criticism that are not well maintained, does not provide security at nights. So, it becomes a challenge once you have that expensive piece of infrastructure, which then requires continuous maintenance. So, you can have them, especially in Mumbai, where you have to separate pedestrian traffic with the motorized traffic, but more often than not for your city, which may not be as large as Mumbai, you would be rather recommended to provide ad grade facilities rather than grade separated access facilities to metro stations or BRTS stations. Try to provide, like we already looked at, covered parking facilities, add grade station access paths. So, these are more attractive, because once you provide grade separated, then people with luggage are not usually want to climb up the stairs and climb down the stairs with it. Old people would not use it. Even people in a hurry would not use it. They would say that, well, I have minimal risk if I cross the road at grade versus if I take this. So, grade separated access has to be very carefully designed and carefully provided. They are not for every location or not even for an average location. They may be for specialized locations. You can have grade separated access points, but mostly you have to have ad grade access to these station areas. The fifth design principle is design your station surrounding areas carefully as well. Do not only look at your station building itself and believe that that is your only jurisdiction that you are planning for or designing for, but also your design should incorporate some of these surrounding areas as well. Make sure that you have good connections, good pedestrian connections. Make sure if there are signalized intersections close to your station areas, the signal timings are such that they benefit the people getting in and out of your station, because that signalized intersection that is close to yours, it should benefit the station users rather than the vehicles that are going through and not stopping at the station. So those signal timings, those pedestrian crossings that are allowing people to get into the station has to be also part of your design of the station building. That often what happens is a transit authority does not have jurisdiction over the surrounding area, and they leave it to another entity to design that. And then when you don't coordinate with that entity, then you end up with a station area with not proper access, and then people, the patronage of public transportation goes down. So rather you take it into your jurisdiction itself, say that okay, 100-meter radius around my station perimeter is what my jurisdiction is, and I will design everything within that jurisdiction, and safely take my user from the station building, from the station area to the urban transportation network of the city. So keep that in mind. Always include the station area in your design. And finally, the passenger waiting area and weather shelter we have already looked at. A very important aspect you have to have, even if you have a basic shelter like that, but it is you rather err towards having the basic shelter than not having it. This plays a huge role in attracting people to ride public transportation, because especially during especially in India, where we have heavy monsoon seasons, summer heat is extreme. So these do provide a lot of comfort when people are accessing public transportation. Of course, some transit centers need to have even more sophisticated facilities, because people are going to be transferring between two modes, for example. So they will be sitting for a longer period of time. So maybe there needs to be eateries and other amenities that needs to be present. So when you design for a station, you need to be thinking about all of these elements. Once now that you have followed all these design principles, now you have to look at certain standards for sizing your different facilities that you provide within the station, right? And many of these sizes you have already looked at when we were individually looking at each of these modes, for example, for their level of service and so on and so forth. But very quickly, you have to have say for example, a minimum pedestrian wheelchair clear path width of 6 feet, with 8 feet, 6 to 8 feet is preferred, right? So when you provide a path, the path cannot be any narrower than 6 feet. Then a wheelchair person would not be able, a person with a wheelchair would not be able to access that station. So such standards are available for, they may not be available for our context in India, but best practices are available, and these are from the best practices, but we can adopt and adapt these standards to our necessity, to our requirements, and that's why the whole point of this class or this exercise is to make you aware of these standards, so that you can take it forward in your city. Similarly, when you are sizing your waiting and shelter area, you should not be just putting in a canopy, for example. You should understand what size of the shelter that will allow you to, or that will allow your passengers to be comfortably seated under the shelter, right? So bus shelters should provide a minimum of 5 square foot per person during the peak period. So there should be at least 5 square feet for one person to be comfortably sitting or standing under a shelter. So that, and based on how many people would be there, then you can determine the size of the shelter in that station, right? Just do not arbitrarily pick a size or pick a length or width of your shade. Again, rail stations, shelters should assume approximately 3.5 to 6 square feet per person. So, there are some ranges, there are some standards, there are some best practices that you need to follow for station waiting and shelter areas. Similarly, for platform elevation, you should always try to have the platform area a little bit above the curb, but however, how much aligned to the footboard that you want to have your platform is something that you have to decide. If you have it at grade with the footboard, then you have to have a much thicker height of your platform. Otherwise, that enables, for example, people with old age, or people in old age, or people with disabilities to easily enter into your transit vehicle, right? If there is a grade separation, if your platform is not level with the bus platform or the rail platform, then there is a level difference. It becomes difficult for people to access it. If there are platform widths can be different based on how platforms are oriented. If you have a center plus a side platform, so if your two rail lines are here and you have a platform here and also two platforms on the other side, then the width of each of the platform would be different, versus if you only have a center platform where both of these lines are being served by only one platform, then the width of that would be different, versus if you have only side platforms on either side and no center platform, then you have your width different. So, all of these have to be thought about for your purpose, for your particular station, and you have to design it accordingly. Platform length is the next element. How long should be your platform, right? How long should be your platform? So, it has been noticed from best practices for light rail transit systems, 270 feet to accommodate a 3-car train. So, a 3-car train could be accommodated into the length of the platform, because no point having long platforms, because in the middle of the urban area you are taking up a lot of space, becomes expensive to build. So, you have to have an optimal amount of platform length also built in, but then you have to have some cushion as well, right? If you increase a car, if you add an additional car to the train, then if you don't have a platform, then you would not be able to add that. So, have some cushion, but then don't have a whole lot of platform, a whole large length of the platform, because then land becomes expensive to build. So, similarly, commuter rails have different lengths, platform length standards. BRT, based on where it is on a highway or an urban arterial, they have different length standards or suggestions or recommendations which needs to be followed. Passenger information is something that is becoming essential, especially if it's a transit center or a transit hub where people wait and for the next bus or the next train to arrive, and they have to have information that is at appropriate locations, so that they should not be able to miss the train or the bus. They could be either static signs, changeable variable message signs, or sometimes a real time information can also be provided to passengers while they are waiting at these facilities. Warning signs, these are usually warning signs that the train or the bus is arriving. So, those kind of systems have to be also in place. These are more for safety and security, and as a rule, systems separate from full roadway warning systems should not be considered standard. So, do not provide a active warning system that provides warning systems for the roadway as a whole. Provide it for your transit system separately, so that you don't have to. For example, if your station is on the is at grade with the road, and the road has a traffic signal associated with it, so you need to have your own standalone warning system as well, that will warn that the bus is arriving or the train is arriving at this station, and so you may be coordinated with the traffic signal at the road, but do not just rely on the road's signaling system, have your own active warning system as well. Finally, the design review process allows you to gives you a checklist of all the items that we just went through, and if you have a checklist and if you go at each of your stations on your metro route or your BRT route and make observations that whether they are following your design principles, whether they are following your sizing principles or not, and once you have this checklist, it is easy to review what are the for example, what are the changes that needs to be done at this station versus what are the changes that needs to be done at that station. Maybe one station is perfectly fine, whereas the other station needs a lot of help. So, this allows you to keep a check on all of your stations in your system and allows you to develop maybe a priority improvement program for improving your station design plans, keeping in mind again that these are done for multimodal transportation system. So, that is it for this lecture series. These are the references from which we have collected all the information. The ITE handbook is the older version, I believe, is available for free. So, you should be able to look it up, and this is one of the best practices that we were able to pick up from the United States. It is a best practice, so you should look at that, but maybe keep in mind that when you are developing it for your city, you have to be catering it to the local conditions. So, in conclusion, today we looked at where does the station area design plan fall in, how is it an intersection between TOD and MMT and station area planning. We looked at transfer terminals and transit centers, how they differ, how they are similar, and then we got into how to design these station areas, what are the 6 design principles, and finally looked at sizing each of the different elements in the station. Thank you very much for your attention.